not path connected actually, because if you're going to take 2 points, okay, and try to draw a curve, that curve has to, go outside actually. Okay, so a closed loop, good closed loop, it's always going to be path connected.
मतलब एक पॉइंट यहाँ पे अगर लें और एक पॉइंट इस सरफेस में तो फिर वो
path is not going to be in the set actually. In other words, the set is the union of D1 and D2 actually. So they are individually path connected, but their union is not path connected actually. Okay? And you can see path connected must be a topological property. In other words, if you take this region and no matter how you mold it actually and do anything with it, doesn't matter. It's not going. It will be still path connected actually. In other words, I mean, if you do this, or you turn it into, this, it's always path connected actually. Anyway, so continuity, path connectedness is preserved by the continuity. ठीक है भाई? Okay. I'm writing a proposition, but without proof. I'm not going to prove it. Okay? It's something that you might going to do in your topology course, but I'm going to use it just. So this is set actually. So try to figure out the difference between this definition and the proposition that I have. So I'm saying let U is a subset of Rn that is path connected. Okay, path connected and open. Okay, and open. So in addition, it's open actually. Then, okay, for any A star and B star in U, we can find a rectifiable curve. Okay? Rectifiable curve. Okay? That joins, in other words, in this manner. Okay? That joins A star and B star. You can see we don't have a rectifiability, condition here. So if you have path connected set and in condition is just open, then you can always find, a kind of a curve, okay, that is going to be rectifiable. In other words, you can reach from one point to another point in this region in a finite amount of time actually. Okay, in a finite amount of time, because you can always find a path connecting the points, and hence you can reach in the finite amount of time. Okay? Because if it is a finite distance, you need finite distance to cover that, finite time to cover that finite distance. Okay? Okay, here you don't have restriction. The P could be anything. Maybe you are going in, so the P is taking you from A to B, but it's going in loops and loops and loops and making, taking some crazy path in which not necessarily the loop is finite actually. Is it making sense? So if we accept this as a fact,
so
we can't give a fact in this course. That's what I'm saying. That if in addition you assume, along with path connectedness, if you assume the openness, then you're going to have an additional benefit.
सर ऐसा कर सकते हैं कि जो हमारा रीजन होगा इन्फिनिटी के जैसा था, अगर कोई रीजन है हमारे पास ऐसे इस शेप का,
नहीं किसी भी शेप का हो सकता है।
नहीं सर, मैं क्लोज और ओपन की बात कर रहा हूँ। ऐसा रीजन है इन्फिनिटी की तरह और वो क्लोज्ड है, तो उस पे हम फाइंड नहीं कर सकेंगे जो रेक्टिफाइबल कर्व होगा, इसीलिए ओपन बोल रहा है।
So you take away that controversial part actually. The boundary can be trouble. Okay. Anyway, so let's treat this as a God-given fact for now, and let's state second fundamental, first fundamental theorem of line integral and prove it. Okay. It's a bit of the patient work, but it's fun too. Okay. It links basically that when the conservative fields are going to be the gradient fields. Okay. So here's the first fundamental theorem of line integral. Okay. So it says this. That imagine you have path connected open set. The path connected open set. Then every conservative vector field on a path connected open set U, in other words with this domain, is gradient field. Okay. So if you consider the all fields, for example, with the domain path connected and open, then the set of all conservative vector fields is going to be the subset of the gradient vector fields, and you can obviously deduce from it that there must be some examples where you have gradient fields which are not conservative. Okay? Let's prove it. So here's the proof. How should we start? So let's take a vector field on U where the U is path connected and open. Okay, so let F be a conservative vector field on U. Okay? So it's a conservative vector field on U. So I would like to say that this F is a gradient field. So if it is a gradient field, I need to do what? I need to construct a potential for it actually. I need to show that yes, there is a potential, there is a phi whose gradient is F. That's what I would like to do. Okay. So what we would like to do, we like to, so we construct potential field, which is a scalar field phi, okay, as follows. Okay. So I need to define a map phi from U into R as follows. Okay. So U looks like this. So let's assume that U is some arbitrary region. Let's U to be an arbitrary path connected set. Okay. So you have this. That's my U. Okay. So this phi must be defined on entire U. So I need to pick an arbitrary point of U, say X. Okay. I need to define phi of X up to. Okay. Let's define phi of X. Can you guess a definition for the phi of X? Think about it. That F is the gradient of the phi. Okay, very roughly think about it. F is the derivative of the phi. Good. Okay? So the phi should be the integral. Okay? It's just intuition, but you have to, but that's how it should be. Actually, I mean, if you take it down to the one dimension, so it should be curves. Okay? Where C is what? Okay. Should say where C is any rectifiable curve. Okay? That should do what? So what kind of curve it should be? So I mean, if I like to put it, where and how should I put it? So I'm saying that C is a rectifiable curve.
Yes.
Okay. Obviously in U, the question is कोई भी दो points नहीं. So we already have 1 point. Okay, so let's take another point. So it should be a rectifiable curve. So let's just start from A and end to my arbitrary point X. You have to keep in mind A is fixed whether A is arbitrary. Okay? Question. A very serious question. Why this map is well defined? So when a map is well defined,
Independent of paths.
what is the meaning of a function being well defined actually?
डोमेन में लाया करना
क्या डोमेन में लाया करना
ये जो हमारा जो रीजन है उसमें अंदर ही लाया करना
है?
है
ये तो मुझे पता है ये नंबर है, so it's in R actually. It has nothing to do with the domain. So the phi of x must be in R.
सर अगर हमारा ऑपरेशन जो है किसी मैपिंग को डिस्टर्ब नहीं करा तो वेल डिफाइंड है या इंसेंस
You should say it precisely. In mathematics. Okay. So in other words, here's the thing. The key thing is, function is a map that takes a value from the domain and assigns it a value in a codomain, but that value should be unique actually. So if you would like to, so it assigns it a number, so I know it's going here, but the question is it unique? Is it unique?
For unique path it would be.
So why it should be unique actually?
It's property of
In other words, why this number should be unique? So can you see the definition?
it's conservative.
It's a conservative vector field actually. It's a conservative vector field. What is the definition of a conservative vector field? Okay, so whose integral is independent of the path joining the paths. No matter what path you take, you should get a similar kind of a curve. So it is. First of all, okay. I must pick a I should say this. I must pick a before asking for the curve actually. Okay. I must pick for. So I'm doing that. So I have U and I picked a fixed point from it. And then I'm taking an arbitrary point. Then why such a curve should exist? Because I know it's path connected. So it's going to give me a curve. Okay. So this curve exists because the region is path connected. Okay. And this map is well defined because the vector field F is conservative. Okay. So if I have to show, now what is my claim? My claim is that if I compute the gradient of the phi, I'm going to get F. Okay. So how can I show? Think over it. Okay. So the claim is that if I compute the gradient of the phi, okay, maybe at the point x, then I'm going to get f at x actually, okay, for every x, right? So that's a vector quantity, which is same as if and only if, that if I take the kth component of the f, it should be same as the kth, so the partial derivative of the phi with respect to the kth component actually. This should be true. So if I show this, okay, then obviously I can put an x here because everything is a function of x. Then I can show this. So that's my target. So I need to compute an integral of the partial derivative. So I have phi with me. If I want to compute the partial derivative of the phi with respect to the xk component, and let's see whether you get the kth component of f or not. So if you get,
So do we know the kth element of f?
I'm sorry?
Do we know about the kth element of f?
No, we don't know. That's what is my. But I know that in phi f is there. F is there. So in phi I have f. So maybe if I differentiate phi partially, I can find k. Let's see. So it's not going to be that trivial, but yes, we can already get that. So what should be the definition of partial phi by partial xk? Can you help me out? So what are the definitions? So how can I define partial phi by partial xk? How you compute a partial derivative of something? What is the definition of it?
We treat other variables as constant
And the kth as a?
kth as a variable.
Okay. So this is same as that you take limit t goes to 0 and I evaluate phi at t plus say xk, let's put a k subscript 1 superscript. Okay. So x, so the x is going to arbitrary and I'm just moving in the direction of the k. Okay. Minus phi of x and everything divided by t. This is what the definition is. Okay. Now, I would like to physically see this, and obviously, for this the t is between 0 and 1. Okay. T is always between. Would that be between 0 and 1? No, not necessarily. Not necessarily. Okay? So you should have it. And I can also write this as, if you remember, there is another way to write it. That you take this phi of x plus t ek. You have to keep in mind that x is a vector and ek is a vector actually. So t ek is a vector with the kth component as a t and the rest are the 0 actually. That you differentiate it with respect to the t and then substitute t equal to 0. Okay. So take the total derivative of the t and substitute t equal to 0. Okay. So in this picture, in this new picture, I would like to see x plus t ek. Where the heck is x plus t ek actually? What does it represents? क्या ऐड करेंगे? इतना डिस्टेंस, but किस किस्म का डिस्टेंस है? ठीक है. But x plus t ek has a specific kind of a.
So ये noun था किसी चीज़ का यार.
So it's sitting on a line actually. That from this point, okay, you are moving in a certain direction for some time over a straight line actually. Okay? And this is x plus t ek. So that's x plus a, this is x plus t ek. Okay? Keep in view, this curve is C and I'm giving this curve a name actually. So what name should I give to this curve? So it must be C, but this C depends on what? It depends on the k, because it's k component, and it should also depend on the t, because for how much time you have traveling along. The t represents that number actually. Okay? Can you give me a parameterization for CKT? You know, this CKT. So what would be the parameterization of this? It's a straight line, you know, not something. So it's so it's like a straight line. So how are you gonna parameterize it? So let me denote it by PK. Okay. Let me denote it by the PKT evaluated at U. So how should I denote it? So it should be X plus PEK. So this must be the parameterization of it actually. Okay. In other words, I have, so X has n components, so it's X1, X2, X3, and in kth component I have Xk plus T, comma, and then Xk plus 1 and up to Xn actually. So only one of the path is there.
यहाँ पे U पे तो dependent
चलो
नहीं
U कर लें, ठीक है, where the U is sitting between. So one actually, I must have a T here as well. ठीक है, U भी होगा और T के actually, ठीक है. So it's a function of a U. This must be the case. Alright, so bit of construction. I know it's a bit boring, but can you see where I am going now? So what should be the next step? Second thing is, can you see these two curves are, you know, adjacent to each other? They are adjacent to each other. So I can treat this curve as a single curve actually. So I can create a single curve out of both by concatenating both. Actually. So let's concatenate them. Okay. So I'll consider the concatenated curve. So if I have a concatenated curve, so what can I do? I can do this. Okay. I can do this. Alright, so I can do this. What would be phi of x plus e tk? I would like to evaluate phi of x plus, t and ek. What would be that? By definition. So the definition says, if you see the definition of the phi, what does it say? So if you insert a point x into it, okay, then it's going to take a path which starts from the A and x ends at x actually. And the image of this phi of x is what? The integral of the path that connects A and x actually. So now I'm substituting x plus tak into the phi actually. So what I'm going to get? So it should be the integral of f. So it should be the integral of f. And it should be the path that connects A with this x plus tek. So it should be which path? So C concatenated with C concatenated with CKT. Right? Why I am writing it? Because I want to compute the derivative of the t and substitute t equal to 0. So I wrote it explicitly now. And I know that if I want to integrate this over a concatenated curve, this is same as that you integrate this on the C plus integrate this on CK. This is going to be the case. Okay? And now differentiate both sides with respect to the t. Okay? So let's differentiate phi with respect to the t. And I'm assuming that there is this x plus etk here actually. Okay? So what would be the derivative of the phi with respect to the t? If this guy depends on the t, so this must be 0. The real thing would be I would like to differentiate this with respect to t over, the curve ck. So this is going to be the interesting. The real thing is, can I compute this? Okay? So can I compute the derivative of an integral? That's a line integral. So I don't know whether I can compute the derivative of the line integral or not, but I know one thing. If I can convert this line integral into the Riemann integral, then I know how to differentiate it with respect to the time, because Riemann integral, so you have this second fundamental theorem of calculus and first fundamental theorem of calculus that tells you that if you want to differentiate, an integral, that would be basically the f. Is it making sense? Good. So let's convert it into the Riemann integral. So how can I convert it into the Riemann integral? By the way, what would be the definition of this? So I will have to apply this definition. So what should I do?
बात यूज नहीं करेंगे सर
So I need to, integrate it over some limits. So I'll put it later. So I need to evaluate f at a path, but which path?
P K T U सर ये
No.
CKG.
Which path? Okay, so it's CKT का path. ठीक है, so it's PKTU. So f of PK T and U. Shall I write there? Okay, so that we can see it a bit more clearly. So you don't have to worry. I mean, you're going to see it's a complicated proof. It's not really a complicated proof. It's just a fun proof. I mean, if you see what is going on. Okay. So I have this phi of x plus TEK, and I want to differentiate it with respect to time, but this guy is equal to the derivative of the t over the f, this CKT. So I would like to compute this integral. So whenever you want to compute a line integral into the curve, then take the parameterization, substitute into the line integral, and multiply it with the derivative of the path of that, curve actually. Take it representing the curves. Okay, so this is going to be d by dt. Okay, and f of pk t of u. Okay, times p prime dot product. So what should be the p prime? But prime should be with respect to what? U or t? So it should be with respect to the u, because u is, the thing that is, or the variable that is parameterizing. So what would be the derivative of pk t with respect to u? So x will go away. Okay. So it's going to be TEK. So let's take the dot product of this with TEK. Okay? And differentiate or integrate everything with respect to, let's be a bit more careful, with respect to du. You're integrating with respect to du actually. Okay? What is the limit for the u? So now I can see that since I'm integrating with respect to the u, the limit should be between 0 to 1. Okay? Question. What would be this dot product? Think of the result of this dot product. But make a substitution. Take V to be ut. Okay? So what would be dV? So it is going to be T du. Right? Roughly. So it's going to be T du because we are changing it to the case of it. So it's going to be T du. And limits would change to d by dt of integral of 0 to 1. Okay? No, not 0 to 1. So it's going to be 0 to t. Yes. Okay?
0 to t.
And f of pkt is basically what? I can write it as this is x plus t ek, writing the value of it, dotted with t du is going to be dv, and dotted with ek. Okay? So I am taking the dot product of ek with this guy. So what would be the result actually? Can you think of it? Okay, so what should I do? Should I get rid of it? Yes. Okay. Maybe like it. So what should be I can say, so this condition is like this. Okay, so the second fundamental, how does the second fundamental theorem work? So you have, so if you have a d by dx is starting from some constant and ending at some x, and you have, say, f of t dt, the output would be, so it's going to be simply f of x.
हाँ